Welcome to the Deep Dive. Today we're navigating the challenging but really crucial landscape of professional certifications, especially for you IT pros focused on server management. It's a field that, well, it just demands constant learning, sharp skills, and we're here to help you get ahead with that. So whether you're maybe fine-tuning your knowledge for a project, prepping for a big meeting, or maybe you're just curious about, the whole world of server infrastructure, you're definitely in the right place. Our mission today, it's all about deepening your understanding. We're jumping into a targeted interactive challenge designed specifically to test and sharpen your CompTIA Server Plus knowledge. Now, this isn't just like a rapid-fire Q&A session. Think of it more like a guided tour. We'll explore the core principles, the common slip-ups, and solid solutions that make for effective server admin, security, hardware management, and, troubleshooting too. We're really aiming for those aha moments,
Yeah.
the ones that make complex ideas click and actually stick.
And that's precisely where the CompTIA Server Plus cert really shows its value. What's fascinating here, I think, is it goes beyond just checking if you've memorized facts. It gives you real, tangible proof of your expertise in those critical areas every IT pro managing servers absolutely needs. Like you said, the goal isn't just passing an exam. It's about truly internalizing these concepts so you can confidently apply them in, actual real-world situations. It's about building that solid foundation, the kind that lets you manage and secure server environments effectively, keep business running smoothly, and keep everything performing optimally.
Absolutely. Practical mastery. That's the key. So here's the plan for this deep dive. We've put together 20 pretty thought-provoking practice questions pulled straight from key CompTIA Server Plus domains. I'll read out each question, give you a moment to think, formulate your answer. Then, our expert here will not only reveal the right choice, but dive deep into the why, explore the implications, practical insights, all that good stuff. We're hitting 4 core domains today: security and disaster recovery, server administration, server hardware installation and management, and finishing up with troubleshooting. So get ready for some real insights. Okay, let's kick things off. We're diving straight into scenarios you're, very likely to see. Not just on the exam, but probably in your day-to-day work too. We're starting with a domain that honestly touches every single aspect of IT. First up, the big one, security and disaster recovery. In today's world, hyper-connected, threats everywhere. Safeguarding server assets, ensuring business continuity, it's not just a best practice anymore, is it? It feels more like an essential need for survival.
Yeah, this domain is all about arming you with the knowledge, keeping data secure, systems resilient, operations running no matter what challenges pop up. Let's get into our first question. What is the primary purpose of a server decommissioning procedure? Okay, is it A, to upgrade the server hardware for better performance, B, to ensure data is securely erased before disposal, C, to test the server's disaster recovery capabilities, or D, to migrate data to a cloud environment? Think about the whole server lifecycle here, right down to the very end. Take a sec.
All right, the correct answer here is B. To ensure data is securely erased before disposal. Right. While, sure, a server's life involves upgrades, DR testing, maybe cloud migrations, decommissioning itself has this really singular critical focus. It's end-of-life security. Don't just think of it as pulling hardware off a rack. It's about preventing a digital ghost from haunting your organization later. Because the risks of insecure disposal, they're huge. Just deleting files, even reformatting, fundamentally not enough. Sophisticated recovery tools can often pull back data, even after standard deletion. That's a massive data breach risk right there. And that's exactly why we rely on secure data sanitization methods. These are designed to make data completely irretrievable. So things like data overwriting, that's writing random patterns over the whole disk, maybe multiple times, rendering the original data gone, depending on how sensitive the data is, or regulations. Maybe it's a single pass, maybe multiple passes, like the DoD 5220.2 standard specifies. For really sensitive stuff or older magnetic media, you might use degaussing. Powerful magnetic fields basically scramble the data on traditional hard drives, tapes, makes it unreadable. And then for the absolute highest level of assurance, physical destruction, shredding, pulverizing, even incineration, the media itself is just gone. Which method you choose often depends on rules like GDPR, HIPAA, PCI DSS. Getting it wrong can mean, massive fines, legal trouble, huge damage to your reputation. So this isn't just good practice. It's a legal and ethical must-do. Protect privacy, protect IP, stop breaches long after that server's gone. It's that final critical security layer.
That's a really powerful point. It really highlights that the end of a server's life is just as critical for security as its peak operational phase, protecting against future problems, not just current ones. Okay, let's look at question 2. A company wants to prevent unauthorized physical access to its server room. Which of the following controls is most effective? Is it A, installing an intrusion detection system, IDS. B, implementing biometric access controls. C, using software firewalls. Or D, deploying network segmentation. Really focus on the word physical here. What stops someone literally at the door?
The correct answer is B, implementing biometric access controls. Yeah, when we're talking physical access, it's about stopping someone from physically walking into that room. Biometric controls things like fingerprint scanners, retina scans, maybe even facial recognition. They directly verify the identity of the person trying to get in, and that gives you an exceptionally high level of security because, well, it relies on unique biological traits, much harder to fake or steal than key cards or passwords, right? Now, an IDS, which is watching network traffic for bad stuff.
Right, that's logical.
Exactly. Or software firewalls controlling network traffic or network segmentation, dividing the network up. They're all vital security tools, absolutely. But they protect against logical or network threats. They don't actually stop someone from opening the door. And a key takeaway here, I think, is that a truly secure server room uses a layered approach. Biometrics might be primary, but you'll often see it backed up. Things like video surveillance, maybe man traps, those little secure vestibules with interlocking doors, one person at a time.
Oh, yeah, I've seen those.
Right. And detailed access logs tracking every entry and exit. This whole multifaceted strategy builds multiple barriers, gives you robust protection for the actual hardware holding your critical data. It's holistic. Acknowledges that a physical breach can bypass even the best digital defenses if that perimeter isn't secure.
That's a critical distinction,
Yeah.
physical versus logical security. It makes you realize, yeah, the best firewall doesn't help if the door's unlocked. Okay, quick practical question then. For listeners maybe managing a remote rack, if full biometrics aren't in the budget right now, what's a good first step to boost physical security?
Oh, that's a great question. Very real-world constraint. Well, if high-end biometrics are out, focus on getting the basics rock solid. So industrial-grade locks, reinforced doors, strong key or access card management log everything, revoke access instantly when someone leaves. Combine that with maybe basic 24/7 video surveillance, even just recording, and clear security policies for everyone. It really raises the bar, makes it harder for casual attempts, and records any serious ones.
That's pragmatic. Good advice. All right, question 3. A company has implemented multi-factor authentication, MFA, for its servers. What is the primary benefit? Is it A, it simplifies the login process; B, it increases the complexity of passwords; C, it enhances security by requiring multiple forms of verification; or D, it reduces the need for password changes? MFA is everywhere now, right? Email, banking. What's its core strength specifically for servers?
And the answer here is C. It enhances security by requiring multiple forms of verification. Yeah, multi-factor authentication, MFA, it's really a cornerstone of modern security, especially vital for server access. It's fundamental strength.
Yeah.
It significantly boosts security by demanding more than just one piece of proof to verify who you are. Typically, MFA needs a combo of at least 2 things from different categories. Something you know, like your password.
Yep.
Right. Then something you have, like a physical token, a code sent to your phone, maybe an authenticator app, or something you are, like a fingerprint or retina scan. This layered approach means even if a criminal steals your password, they're still blocked without that second separate factor. It drastically shrinks the attack surface for common threats, like credential stuffing or phishing. Now, the other options, well, they're incorrect. MFA usually adds a small step, so it doesn't simplify login. And while it works with strong password policies, it doesn't inherently make passwords more complex itself. Plus, it definitely doesn't reduce the need for regular password changes. Good password hygiene is still critical, even with MFA. If we zoom out a bit, MFA is especially crucial for things like remote administration logging in from maybe an untrusted network, or for those mission-critical systems where any breach would be, well, catastrophic. It just significantly raises the bar for unauthorized access, makes it way harder for bad actors to get in. It's pretty much non-negotiable for enterprise security these days.
That's a solid explanation. So yeah, even if a password gets swiped, attackers hit another wall, like needing the key in the alarm code. Much stronger defense. Okay, moving to question 4. This one's actually question 6 from our source material. An organization has a disaster recovery plan, includes offsite backups. Which of the following is a critical step to ensure the effectiveness of this plan? Is it A, regularly test the recovery process; B, encrypt all data before backup; C, perform daily network scans; or D, update the recovery plan quarterly? Having a plan is one thing, right? But knowing it actually works when disaster strikes, that's different. What really validates your DR strategy?
The correct answer is A. Regularly test the recovery process. Look, encrypting data, doing network scans, updating the plan, these are all super important parts of a good security and resilience strategy, no doubt. But none of them alone confirms you can actually get your data back when a disaster hits. Regular proactive testing is absolutely paramount. It's the only way to verify the recovery process itself works, is efficient, and meets your RTO and RPO goals. This means actually trying to restore data from those offsite backups into a test environment, ideally. Then you check. Do systems come back online? Do apps work? Is the data intact, consistent, usable? It's a common mistake to assume successful backups mean successful recovery. I mean, think about the horror stories. Companies doing backups for years, disaster strikes, and bam, tapes are corrupt, recovery software is misconfigured, the procedure was flawed because no one practiced it, or the media is just inaccessible. All those backups. Useless at the critical moment. Testing finds these weaknesses before a real disaster. Gives you a chance to fix things, train people, ensure recoverability. It's not enough to have the fire extinguisher. You need to know it works, and everyone knows how to use it. That validation can save an organization.
Powerful analogy. Exactly like having a fire drill, not just the extinguisher, knowing everyone gets out safely and the gear works. It's the practice that matters, not just the theory. All right, fifth question in this domain. This is question 9 from the source. A server admin needs to ensure data is secure both at rest and in transit. Which combination of technologies should they implement? Options: A, data encryption and VLAN segmentation; B, data encryption and SSL/TLS; C, RAID 6 and VLAN segmentation; D, RAID 6 and SSL/TLS. Okay, this covers 2 major states of data. How do we protect info, whether it's just sitting there or moving across the network?
The correct answer here is B, data encryption and SLTLS. Right. This one gets right to the heart of comprehensive data security, protecting data through its whole life cycle, no matter its state. Let's break it down. Data at rest, that's data stored on disks, SSDs, tapes, in databases, whatever. To secure that, data encryption is essential. This could be full disk encryption, FDE, like BitLocker or LUKS, maybe using a TPM ship for keys. Or it could be file-level encryption for specific sensitive files, or maybe database encryption. The point is, if someone gets unauthorized physical access, the data is unreadable without the key.
Prevents a breach right there.
Exactly. Then you have data in transit, data moving across a network internally over the internet to the cloud. For that, SSL/TLS. Secure sockets, layer transport, layer security is the standard. It creates an encrypted tunnel between 2 points, say a browser and a server. It involves that complex handshake, exchanging certificates for authentication, setting up a secure key for the session, protects against eavesdropping, tampering. Now the other options, RAID, like RAID 6, that's for redundancy, protecting against drive failure, not encryption. And VLAN segmentation divides the network logically. It helps security by isolating traffic, sure, but it doesn't encrypt the data packets themselves. So yeah, the combination of data encryption for at rest and SSL/TLS for in transit gives you that strong end-to-end protection.
That is a powerful combination. End-to-end protection, whether data is sitting still or flying across the wire, shows a really comprehensive security approach. Okay, so we've certified our servers, planned for disaster, but what about the daily grind? Let's shift gears now. Focus on the day-to-day operations, the proactive stuff that keeps these complex systems humming. Welcome to server administration, keeping things smooth, efficient, thinking ahead. We'll kick off with question 6, which is question 1 for this domain in the source. A server administrator is monitoring server performance. Which metric is most important for identifying potential memory bottlenecks? Options: A, disk read-write speed; B, network latency; C, CPU utilization; D, memory usage. Performance dips, you suspect memory. Where do you look first?
The answer here is D, memory usage. Yeah, when you're hunting for a memory bottleneck, consistently high memory usage is your most direct, most critical clue. If a server is always showing its RAM is nearly full, it means the OS and apps are struggling. They can't keep everything they need in active memory. And that leads to swapping or paging. The OS starts using the hard drive as virtual memory, shoving stuff there that doesn't fit in RAM.
Right, and disks are way slower than RAM.
Orders of magnitude slower. It's like, imagine trying to work on a huge project, but every time you need a piece of info, you got to walk across the office to a dusty filing cabinet, find it, bring it back, put it back, instead of having it right on your desk.
Yeah, that would grind things to a halt.
Exactly. That's the performance hit the server takes. It severely degrades responsiveness, app performance. Now, disk speed, network latency, CPU usage vital metrics, sure, but they point to bottlenecks elsewhere. Storage I/O, network issues, or processing power limits. High memory usage, which you can see in tools like Task Manager, Resource Monitor, or HTOP, free H on Linux. That directly points to a lack of physical RAM being the bottleneck. Monitoring this is key for capacity planning.
Great analogy. Really makes it clear. Like a car needing fuel tanks always empty, it won't run well no matter how good the engine is. You need enough gas in the tank. Okay, let's tackle question 7, which is question 2 from the source. What is the primary benefit of implementing VLANs in a server environment? Options: A, increased physical security; B, improved network performance; C, simplified cabling; D, enhanced data encryption. VLANs, they're fundamental in networking, especially complex server setups. What's their main superpower?
The correct answer is B, improved network performance, right? VLANs, virtual local area networks, they're a core part of modern network design and their main benefit in server environments. Definitely improve network performance and better manageability. How? Well, they logically segment traffic at layer 2, the data link layer. Think of it like creating separate lanes on one physical highway. Different traffic types flow without interfering. So you can separate, say, application server traffic, admin traffic, maybe SAN traffic, guest access. Each gets its own VLAN.
Keeps things tidy.
Exactly. And crucially, this segmentation significantly reduces broadcast domains. In a flat network, broadcast traffic goes everywhere. In a big network that eats up bandwidth, CPU cycles, slows things down. By keeping broadcast traffic within its own VLAN, you minimize that overhead. Result: better organization, easier management, and critically better performance because there's less congestion. Now, VLANs do help security by isolating traffic, making it harder for attackers to jump between segments. And they can simplify logical network design. But they don't directly boost physical security, simplify physical cabling, or encrypt data. In more advanced setups, VLANs are often the basis for microsegmentation, applying even finer security policies to individual workloads. Enhances both security and performance.
So, better performance, better organization. A big win for network admins, making things flow smoother, more predictably, creating order from potential chaos. All right, on to question 8, question 3 from the source. Which of these best describes the purpose of server clustering in a high availability environment? Options: A, to consolidate multiple servers into a single physical unit; B, to distribute workloads across multiple servers for load balancing; C, to ensure continued operation by providing failover capabilities; D, to increase the performance of a single application. High availability, absolutely key for critical services. How do clusters mainly help achieve that uptime?
And the answer is C, to ensure continued operation by providing failover capabilities. Server clustering is specifically designed for high availability, HA. You have 2 or more independent servers, called nodes, working together. They constantly monitor each other's health and the status of the services they're running. The core idea is failover. If one server in the cluster fails hardware, OS crash, app fault, whatever, another server in the cluster automatically, seamlessly takes over its workload. This ensures services keep running, minimizing downtime to maybe just seconds, sometimes even milliseconds, keeps users connected, business going.
So it's all about resilience.
Exactly. Now, clusters can often be set up for load balancing, option B, spreading workloads around. But that's often secondary, or a related tech working alongside clustering. Load balancing is about performance optimization. Clustering is fundamentally about resilience, redundancy, preventing that single point of failure. It's not about consolidation A, that's more like virtualization. And it's not just about boosting a single app's performance D. The real value shines with mission-critical stuff where downtime is incredibly costly. Think banking, e-commerce, critical patient systems, they just cannot go offline. Clustering provides that safety net.
That really clarifies it, like having a backup pilot ready to take over instantly if the main one has an issue. Plane keeps flying. Essential for anything that absolutely cannot fail. Okay, question 9, which is question 5 from the source. A server admin is setting up a new server role to host web applications. Which server role should they install? Options: A, file server; B, print server; C, web server; D, database server. Pretty straightforward. Matching the tool to the job. What's the right role for hosting web apps?
Correct answer is C, web server. Yeah, this one's fundamental, but absolutely core. If you need to host web apps, serve web content, you need the web server role. This role gives you all the services, protocols, infrastructure needed. On Windows Server, that usually means installing ISI, Internet Information Services. In the Linux world, you're looking at things like Apache HTTP Server or Nginx. These web server apps handle client requests, HTTP, HTTPS, grab the web pages, HTML, CSS, images, process dynamic stuff, PHP, Python scripts, etc., and send it back to the browser.
Does that one specific job?
Precisely. Contrast that with a file server A, which is for sharing files. A print server, B, manages printers. And a database server, D, hosts database systems like SQL Server, MySQL, PostgreSQL. Now, a complex web app might use a database server, might rely on file storage. But its main delivery mechanism, its interface with users, that's always handled by the web server role. It's about picking the right specialized tool. You wouldn't use a hammer for a screw, right? Same idea here. Each role has its specific crucial function.
Simple but fundamental. Use the right tool for the job, for efficiency, and, well, proper function. Okay, final question in server admin, question 10, which is question 6 from the source. Routine check. You see a server's CPU utilization is consistently above 90%. Best initial action. Options. A, immediately restart the server. B, install additional CPUs. C, investigate the processes consuming high CPU resources. D, upgrade the server's RAM. Ah, the high CPU headache. Common problem, CPUs maxed out constantly. What's the smart first move to figure out what's really going on?
The correct answer has to be C. Investigate the processes consuming high CPU resources.
Look, seeing CPU constantly over 90%, that's a major red flag, a serious performance bottleneck. But the absolute best initial step is always diagnosis, not drastic action. You got to put on your detective hat. Figure out what exactly is eating all that processing power. Use your OS tools. Windows, Task Manager, Resource Monitor. Look at processes, sort by CPUs, see what's hogging it. Linux, tools like top, htop, maybe SAR for historical data. See CPU usage per process.
Find the culprit.
Exactly, because the cause could be anything. A runaway app, maybe a memory leak, misconfigured service, malware, or maybe it is just legitimate high demand, meaning the server's undersized, just restarting. A. Might give temporary relief, but the problem will likely come right back. Addresses the symptom, not the cause. Installing more CPUs, B, or upgrading RAM, D, those are hardware fixes, expensive, and probably premature before you know why the CPU is overloaded. You might be trying to fix a software issue with hardware, inefficient, costly. First, gather evidence, understand the problem, then figure out the solution. That methodical approach is key to effective troubleshooting.
Crucial point, be a detective, not just a button pusher. Understand the what before you jump to the how. Rushing in without diagnosis often makes things worse. Okay, we've covered admin. Now let's get really hands-on, the physical layer. How we install, configure, manage the actual hardware that makes servers work. This domain is about the tangible stuff, efficient racking, critical cooling, the internal bits that define a server's power and resilience. Let's start with question 11, which is question 1 from the source for this domain. Which capacity planning consideration is crucial when installing new storage systems in a server environment? Options. A, the color of the storage device. B, the future growth of data storage needs. C, the brand of the storage device. D, the number of USB ports available. Thinking long-term is always key in IT, right? What's the most vital thing to foresee when planning new storage?
The answer is definitely B, the future growth of data storage needs. Yeah, this question hits on a fundamental and sometimes painfully learned lesson in IT planning. Data storage needs, they almost always grow, relentlessly, often faster than you predict. So when you're putting in new storage, anticipating and planning for that future expansion is absolutely paramount. If you only provision for what you need right now, you'll quickly find yourself scrambling, needing more space, doing costly, disruptive, unplanned upgrades, or worse, systems crashing because they're out of capacity.
Yeah, that's a bad day.
A very bad day. Underestimating storage growth has real financial and operational costs. Unexpected spending, diverting IT staff, potential service outages affecting the business. And good capacity planning is more than just guessing. It involves looking at historical growth, understanding business plans for new apps or data retention rules, often building in a buffer. It also means thinking about scalable storage designs, adding drives, expanding to a SAN or NAS, maybe using cloud storage. Things like the color A, brand C, or USB ports D. Almost entirely irrelevant for fundamental capacity planning. The core takeaway, simple but profound, plan for tomorrow, not just today, especially with data.
That's solid advice. Always plan for tomorrow. Assume data will multiply because it probably will, and be ready. Okay, question 12, which is question 3 from the source. Planning a new server rack installation. Which factor is most critical for optimal cooling? Options. A, the color of the server rack. B, the height of the server rack. C, the arrangement of hot and cold aisles. D, the number of servers in the rack. Cooling. Non-negotiable in a data center. What's the big picture strategy to stop overheating, keep systems alive longer?
The correct answer is C, the arrangement of hot and cold aisles. Right. While sure, the number of servers impacts heat, and height or color might matter a tiny bit practically, the most critical factor for efficient cooling is the strategic setup of hot and cold aisles. This design principle is just fundamental. Servers go in rows and racks, and the rows are organized deliberately. Cool air from the cooling units, the CRXE units, gets delivered precisely into designated cold aisles. These are usually at the front of the rack, so servers pull in that cool air.
Intakes out.
Exactly. Then, after the air passes through the server, picking up heat, the hot exhaust air is pushed out the back into dedicated hot aisles. And these aisles are carefully separated, contained, to stop that hot air mixing back into the cold aisles. That separation is vital. It ensures servers always get cool air, prevents hot spots, improves hardware life, and drastically cuts the power needed for cooling. Without proper hot-cold aisle containment, sometimes enhanced with actual physical barriers, cooling is inefficient, expensive, less effective, leads to higher temps, more failures.
That really is where it gets interesting. Simple concept, huge impact on power use and hardware life. Just smart airflow management, really. Question 13, which is question 5 from the source. Best practice when performing firmware upgrades on server hardware. Options. A. Upgrade all servers simultaneously to save time. B. Ensure a backup of current configurations is available. C. Disable all network connections during the upgrade. D. Use wireless connections to download firmware updates. Firmware upgrades can be scary, right? High stakes. What's your essential safety net when you're messing with that low-level hardware code?
The answer has to be B. Ensure a backup of current configurations is available. Yeah, firmware upgrades are critical and they definitely carry risk. Firmware is that low-level software embedded in the hardware BIOS UEFI, RAID controller firmware, network card code. A failed or a bad firmware upgrade can potentially brick the hardware, make it completely unusable. So having a meticulous backup of your current configs, BIOS settings, RAID configs, network settings, anything specific is an absolutely essential best practice.
Your rollback plan.
Exactly. If the upgrade fails or the new firmware causes unexpected problems, that config backup is your way back, lets you revert to a known good state, prevents long downtime, data corruption, maybe even needing to replace hardware. Imagine upgrading a RAID controller firmware and suddenly the array vanishes, no config backup, recreating it, restoring data. Nightmare. Upgrading all servers at once. A. Generally way too risky. If the firmware's flawed, boom, massive outage. Disabling network connections. C. Usually not needed, might even hinder the process if it needs downloads or remote tools. And using unreliable wireless. D. For critical firmware downloads. Strongly discouraged. Use stable wired connections to avoid corruption. Best practices often include testing in a staging environment first, understanding dependencies. It's all about preparation and having that solid rollback plan.
It's like saving your work before hitting print. Always want that fallback, especially with something as fundamental as firmware. All right, question 14, question 6 from the source. Primary purpose of using hot swappable components in a server environment. Options. A. To improve data encryption. B. To allow component replacement without shutting down the server. C. To reduce power consumption. D. To increase the server's processing speed. This feature, total lifesaver for uptime, keeping critical services running. What's its core benefit?
The correct answer is B. To allow component replacement without shutting down the server. Yeah, hot swappable components are incredibly valuable, especially in environments needing high availability, minimum downtime, which is, let's face it, pretty much every server environment now. These are parts hard drives, SSDs, power supplies, fans designed to be safely removed and replaced while the server is running. No interruption to services. The primary purpose, exactly that. Letting admins do maintenance, replace failed parts, even upgrade without powering down the server.
Huge for minimizing downtime.
Absolutely. Think about it. A drive fails in a RAID array. With hot swap, admin pulls the bad drive, slides in a new one. The RAID controller starts rebuilding automatically using parity or mirroring, all while the server keeps serving users. Avoids a costly disruptive shutdown. Hot swap doesn't directly improve encryption. A. Reduce power. C. Or boost processing speed. D. If unique benefit is enhancing operational continuity. Directly impacts RTO by allowing faster return to full redundancy.
So maximum uptime, happy users, less stress for the admin, maintaining continuous service without skipping a beat. Invaluable. Final question for hardware. Question 15, question 8 from the source. Purpose of out-of-band management in server hardware. Options. A. To perform firmware upgrades remotely. B. To manage network traffic efficiently. To monitor server performance metrics. D. To access and manage servers independently of the operating system when the server itself isn't cooperating, may be totally frozen. This is your secret weapon. What critical function does it enable?
The correct answer is D. To access and manage servers independently of the operating system. Out-of-band, OOB management, absolutely indispensable for server admins today. Often done through dedicated hardware like IPMI, HPILO, Dell DRAC, Lenovo's xClarity controller. Its core purpose is to give you a dedicated, separate management channel, operates completely independently of the server's main OS and its primary network connection.
That independence is key.
It's everything. It means even if the OS crashes, hangs, or the main network fails, you can still remotely access and control the server. With OOB, you can power cycle it remotely, hard reboot, view the console output like you're standing there, Check hardware sensors, temps, fans, power, reconfigure BIOS CUFI settings, even do a full OS reinstall by mounting remote media. And yes, you can do firmware updates, option A via OB, or monitor some metrics C, but those are functions enabled by OBUMP. Its defining characteristic, its primary benefit, is that critical independence from the main system. Invaluable when a server's locked up, kernel panic, lost primary network. It's like having a separate, always-on connection straight to the server's core controls, no matter what the main system is doing. Drastically cuts the need for physical chips to the data center.
That's a profound distinction, like a separate, always-on connection to the server's deep controls, regardless of the main system state. Critical control, even when everything else goes dark. Okay, we've hit security, admin, hardware. Now let's tackle the art and science of troubleshooting. Diagnosing, fixing problems when they inevitably pop up. This is where critical thinking really comes into play, right? Bringing systems back from the brink. Often the most challenging part, but maybe the most rewarding too. First question here, question 16, which is question 1 from the source for troubleshooting. Server fails to boot. Displays missing operating system error. What should you check first? Options: A, the server's network configuration; B, the boot order in BIOS Wi-Fi settings; C, the server's cooling system; D, the user account permissions. Ah, the classic startup mystery. Server can't find its own brain. Where do you logically start looking?
Correct answer is B, the boot order in BIOS Wi-Fi settings. Yeah, when you see missing operating system, it's a very specific symptom. Almost always means the server can't find or load its OS. Typically, the server's firmware BIOS or the newer UEFI is trying to boot from the wrong device, or maybe a device that isn't bootable. It follows a predefined sequence.
Tries one, then the next.
Exactly. Tries each device in order. If it runs through the list and finds nothing, you get that error. So the first, most logical step, get into the BIOS UEFI settings during boot. Hit F2, F10, DEL, whatever the key is, right at power on, and check the boot order. Make sure the primary boot device is set correctly to the driver volume where the OS actually lives, internal disk, SSD, RAID volume, common causes. Leaving a USB stick or CD/DVD in, and it tries to boot that first. New hardware changing the priority. Maybe a faulty boot sector on the OS drive itself, though you'd check boot order before digging into disk diagnostics usually. Or the drive itself failed. Network config A, cooling C, user permissions D. Totally unrelated to finding the OS during initial boot. Those problems show up way later. It really shows how often simple configuration checks solve seemingly big problems. Always check the basics first.
Spot on. Often the simplest things trip you up. Check the foundations. If the server doesn't know where its OS is, nothing else matters until that's fixed. Okay, question 17, question 2 from the source. Server's backup fails every night at the same time. Most likely cause. Options: A, the server is rebooting during the backup window; B, the backup software license is expired; C, the network connection is lost intermittently; D, the backup destination is out of space. Consistency, powerful clue. Even in failure, backup fails same time every night. What's the most common predictable reason for that pattern?
The answer is D. The backup destination is out of space.
When something fails with that kind of unwavering consistency, same time, every single night, it strongly points to a recurring, predictable issue, usually resource-based. And among these options, the backup destination running out of space is incredibly common for scheduled backups. Over time, backups pile up, new data gets added. If that destination storage isn't managed or scaled properly, eventually the disk or share or cloud bucket fills up. When the scheduled job tries to write data and hits that limit, it fails. Consistently. Same time every night, until more space is available.
The pattern gives it away. Exactly. Let's think about the others. Server rebooting. A. You'd likely see other system impacts. Logs would show the reboot, different failure signature. Expired license. B. Would probably stop the job from even starting, or give a license error, not fail mid-process at the same time. Intermittent network loss. C. Well, intermittent is the key word there. Would cause sporadic failures, not a precise nightly pattern. This really shows the power of pattern recognition in troubleshooting. The server is basically telling you the problem if you're paying attention to the logs and monitoring destination capacity proactively.
Great demonstration of troubleshooting by pattern. Pay attention to consistency. The server's practically shouting the problem if you listen to the clues. Question 18, question 3 from the source. After a recent patch update, the server application fails to start. Best first step in troubleshooting. Options: A, uninstall the patch immediately; B, check the application logs for specific errors; C, reboot the server; D, restore the server from the last backup. Post-update problems. So common in IT. Something breaks right after a change. Where do you look first for the most specific answers?
The best first step is absolutely B. Check the application logs for specific errors. When an app fails right after a patch, your primary, most efficient source of info is always the application's own logs. And maybe the system event logs, too. These logs are designed to record events, warnings, and crucially detailed error messages. They can tell you exactly why the app failed. Things like missing dependencies, config file problems, permission issues, service startup failures, incompatibility between the patch and the app.
The details are in the logs.
Usually, yes. Without checking logs first, you're basically troubleshooting blind. Uninstalling the patch immediately, A. Rebooting, C. Restoring from backup, D. These are all more drastic, time-consuming actions. They might be necessary eventually, maybe as a last resort, but only after you've diagnosed the root cause. Rolling back without understanding why it broke might not even fix it or could cause other problems. That's why good patch management testing and staging clear rollback plans is so vital. But right after a failure, logs are your first, best bet for understanding why. The server often tells you what's wrong if you know where to look.
Powerful reminder. The server usually tells you what's wrong. If you know where to look and how to listen, let the system give its report before taking drastic steps. Question 19, question 4 from the source. A server isn't responding to ping requests, but other servers on the same network are reachable. Which troubleshooting step first? Options. A. Check the server's firewall settings. B. Replace the server's network cable. C. Reboot the switch. D. Update the server's BIOS.
Okay, one specific server goes silent on the network. Its neighbors are chatting away fine. What's unique to that server that you should check first?
The correct answer is A. Check the server's firewall settings.
Right.
If just one server isn't responding to ping, but others on the exact same network segment are fine, that immediately points to a local issue on that server, not a general network problem. And the most common, often overlooked reason in this specific scenario: the server's own firewall settings. Firewalls built into the OS like Windows Defender Firewall or Iptable's Firewall on Linux, or maybe a host-based security agent, are frequently set up to block ICMP packets.
Which ping uses? Exactly. Ping uses ICMP echo requests and replies. Blocking ICMP is a standard security hardening step. Makes a server less visible to simple network scans. So before you start swapping cables, B, rebooting switches, C, or messing with BIOS updates, D, check the local firewall config on the unresponsive server first. It follows that principle of isolation. One device acts differently. Look at what's specific to that device. Check firewall rules. See if ICMP is blocked. It's not always a hardware issue. Sometimes it's just that digital bouncer at the door doing its job, blocking specific traffic, making it look like a connection problem when it's actually a security setting.
Great distinction. Not always hardware, sometimes just the digital bouncer. Firewall might be doing exactly what it's told, making it seem like a connectivity issue. Okay, our final question for this deep dive, question 20, which is question 10 from the source. A server's RAID 5 array shows a degraded status. What is the most appropriate action? Options. A. Replace the failed drive and rebuild the array. B. Immediately shut down the server to prevent data loss. C. Convert the RAID 5 array to RAID 0 for better performance. D. Ignore the warning and continue normal operations. Degraded RAID array. That's a critical flashing red light. What do you do when you see that warning?
The correct answer, the most appropriate action, is A. Replace the failed drive and rebuild the array. Okay, when a RAID 5 array goes degraded, it means one drive has failed. But because RAID 5 uses distributed parity, the array can keep running even with one failed drive. Your data is still accessible, apps usually keep going, and this is a critical warning. You've lost your redundancy. Your safety net is gone. If another drive fails before you replace the first one and rebuild, catastrophic, unrecoverable data loss for the whole array.
You're running without protection.
Exactly. So the most appropriate and urgent action is to replace that failed drive ASAP. Physically swap it out. Once the new drive is in, the RAID controller starts the rebuild process. Uses the parity info from the good drives to reconstruct the data onto the new one. This restores full redundancy, brings the array back to a healthy state. Let's quickly look at the others. Shutting down immediately. B. Usually not needed unless you suspect more failures are imminent. The system's designed to run degraded, albeit slower and riskier. Converting to RAID 0C, absolutely disastrous. RAID 0 has no fault tolerance, any drive fails, all data is gone. Doing this in a degraded state guarantees beta loss. Ignoring the warning. D. Extremely negligent, incredibly risky. You're just waiting for that second drive to fail and lose everything. This whole scenario is why we use RAID in the first place, resilience against single drive failures. But that resilience only works if you act promptly on the warnings to restore it. It ties into MTTDL, mean time to data loss. Running degraded massively increases that risk. Swift action is crucial.
That's a profound takeaway. This is why we have RAID. But that syncing it is only useful if you act on the warnings immediately, like finding a hole in your parachute patch-up before you need it. Hashtag wrap-up quiz segment. Wow, okay. That was definitely a comprehensive workout for a CompTIA Server Plus knowledge. How did you find that challenge? Whether you maybe aced every question, which is impressive, or perhaps pinpointed a few areas where you want to dig deeper. The goal here is always greater insight, practical mastery. We just covered a huge range: security, admin, hardware, troubleshooting. Really core stuff.
Absolutely. And this raises an important question, I think, for every learner. It's not just about picking the right multiple choice answer, is it? It's about truly grasping the concepts behind it so you can apply them confidently, effectively in any real world situation you hit. That detailed explanation of why an answer is right, and just as importantly, why the others are wrong. That's where the real lasting learning happens. It solidifies your knowledge, sharpens your thinking, builds that practical intuition you need for managing complex server environments. Hashtag #, accelerating your CompTIA server plus preparation with FlashGenius.
So if today's deep dive sparked your curiosity even more, or maybe highlighted some areas where you feel you could use more focused study, we've found a really exceptional resource designed to help you not just master these concepts, but actually accelerate your whole certification journey. Because let's be honest, studying for these certs can feel overwhelming sometimes, right? So much material, finding an efficient path. It's tough. And that's where FlashGenius comes in. They genuinely offer what they call a smarter way to prep for demanding exams like CompTIA Server plus Bain. It's really engineered to cut through the noise, get you exam ready efficiently. Let's explore some key features and how they could help you. First up, tailored learning paths. They mentioned AI-guided paths. What does it actually mean for someone studying?
Well, what's truly fascinating here is how intelligent it is. An AI-guided path gives you this personalized step-by-step roadmap. It adapts dynamically to your goals and, importantly, where you are right now knowledge-wise. So instead of just dumping a generic curriculum on you, FlashGenius uses AI to figure out what you already know and, crucially, where your specific gaps are. So it focuses your effort.
Exactly. You get to bypass topics you've already mastered, cuts down wasted study time dramatically, ensures every minute you spend is super productive. It's personalized learning, really dialed up, meaning faster prep, no wasted effort.
It sounds incredibly efficient, a real game changer for busy people. And speaking of practice, they have both domain and mixed practice modes. So you can drill down, but also simulate the real thing.
Precisely. And that flexibility is key. You can jump into domain practice mode, really master specific areas like the security questions we did, or maybe complex troubleshooting, build that foundation. Then, when you feel solid in those areas, you switch to mixed practice. That simulates the actual exam, pulling questions from everywhere, ensures your balance, helps you see connections between domains, gets you used to the feel of the real test.
And practicing under timed conditions? That must be huge for testing nerves. Tell us about their real exam simulations. Oh, it's invaluable. The exam simulation mode in FlashGenius meticulously mirrors the real test environment. Same question types, realistic time limits, an interface that feels like the real deal. This authentic practice is crucial. It helps you learn to manage your pacing under pressure, handle the cognitive load, build confidence, so you walk into the official exam feeling prepared, not surprised or rattled by the format or the clock. Turns the unknown into something familiar.
Right. And for mastering all those definitions, acronyms, flashcards are classic. How does FlashGenius handle those?
They've really elevated the flashcard experience, made them interactive and smart. They're crafted to be super efficient for reinforcing key topics, definitions, those often confused acronyms. Great for initial learning and absolutely vital for that last-minute revision. It's not just passive review. It actively engages your memory, helps you retain knowledge longer, recall it faster when it counts on exam day.
I really like the idea of turning mistakes into learning opportunities. How does their smart review with AI insights actually work?
Yeah, this is where their AI really shines, I think. It goes way beyond just right or wrong. Smart Review gives you intelligent, granular feedback. It explains why you made a mistake, then gives targeted, in-depth explanations of the correct concept. It's not just an answer key. It's like having a personalized tutor. It helps you understand the underlying principles you missed. Fundamentally stops you from making the same mistake again. Turns every wrong answer into a really valuable learning moment.
And learning from common mistakes sounds like a great shortcut.
seeing the traps before you fall in.
It absolutely is. FlashGenius uses insights from thousands of past learners, analyzes common pitfalls, areas where people stumble frequently. By highlighting these common traps during your practice, it helps you anticipate and avoid the errors that trip others up. It's like having an experienced guide showing you the tricky spots on the trail so you can step around them. Optimizes your learning, boosts your success chances significantly.
And multilingual support 9 languages. That's huge for a global audience. Breaks down barriers.
Absolutely. Instant translation makes certification prep genuinely accessible worldwide. If English isn't your first language, or you just grasp technical stuff better in your native tongue, FlashGenius gives you that flexibility, empowers you to study in the language you understand best, removes a major hurdle for many talented learners.
And even a built-in productivity tool, the Pomodoro timer. Seems like they've really thought it through.
The Pomodoro timer is a brilliant addition based on solid science, integrates right into the platform, helps you structure study into focus bursts, usually 25 minutes on, short break. Proven to boost productivity, concentration, retention, keeps your study sessions smarter, more efficient, helps fight burnout, keeps your mind sharp.
So FlashGenius really sounds like a one-stop shop. Everything you need, all in one place.
Yes, exactly. Beyond the smart practice questions and simulations, you get comprehensive curated resources, study guides, cheat sheets, other materials, all aligned with the CERT objectives. This integrated approach means no juggling multiple platforms, hunting for reliable info online, piecing things together. Everything's organized, cohesive, user-friendly. Simplifies the whole prep process.
Okay, so there are other tools out there. What really makes FlashGenius stand out from, say, Pocket Prep or WizLabs?
Well, if we connect this to the bigger picture, FlashGenius really seems to differentiate itself by blending that cutting-edge AI guidance with engaging gamified learning. And they have things like CyberWordle, security matching games, plus those smart productivity tools, all in one platform. Other tools like Pocket Prep, solid for basic practice, WizLabs, great for comprehensive practice tests, but they often lack that deeply interactive, AI-driven, gamified experience FlashGenius provides. FlashGenius is positioned as this modern, AI-powered alternative, makes learning more engaging, efficient, and ultimately, I think, more effective.
So it's not just about passing the exam, but really prepping you to succeed in your career with a deeper practical understanding.
Precisely. At the end of the day, knowledge is most valuable when it's deeply understood and confidently applied. FlashGenius seems built to ensure you not only pass, but come away with a robust, practical grasp of server concepts. That empowers you to apply your skills confidently in your job, enhances your career prospects, makes you a more effective IT pro overall. #outro.
Your CompTIA Server Plus certification journey, it really doesn't have to be overwhelming. With the right tools, a smart strategy, passing on your first attempt is definitely within reach. And FlashGenius clearly aims to provide that kind of comprehensive intelligence support. So, ready to level up your career, accelerate your certification success, we really encourage you to check out FlashGenius. Start their free practice today, see the difference for yourself. Head over to their website, explore what they offer for Server Plus and lots of other key IT certs.
And this raises, I think, an important final question for all of us. Server environments are evolving so rapidly, right? Advanced virtualization, containers, edge computing. As this happens, what new skills, what forward-thinking approaches will you cultivate? Not just to manage, but to truly innovate and secure this vital backbone of our digital world. Because the learning journey in IT, it never really stops. It's continuous and, frankly, pretty exhilarating.
A fantastic thought to leave everyone with, and a great reminder that true expertise is always a continuous pursuit. Thank you so much for joining us on the Deep Dive today. We really hope this exploration into CompTIA Server Plus has been enlightening and empowering for you. Until next time, keep learning, keep growing, and keep diving deep.